Hello guys, welcome back to my YouTube channel. Today I am going to solve day 24 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 995, minimum number of k consecutive bit flips. Okay, so in this problem you are given a binary array nums, okay, and an integer k. Okay, a k bit flip is choosing a sub array of length k. Okay, so we have to choose a sub array of length k from this nums array. Okay, and we have to simultaneously changing every 0 in the sub array to 1. Okay, this is what we need to do, and every 1 in the sub array to 0. Okay, and we have to return the minimum number of k bit flips required so that there is no 0 in the array. Okay, if it is not possible, then in that case we have to simply return -1. Okay, a sub array is contiguous part of an array. Okay, so now let's see this example one. Okay, so in this example one, this is a nums array given to me, right? So if let's say I choose this just this sub array, okay, and let's say I have flipped this bit to 1. Okay, so this is one operation, right? If I just choose this value, okay, this sub array 0, and I just change it to 1, okay, then you will see that all the elements in my num array are now 1 1 1. Okay, I have changed all the elements in my num array to 1, right? And how many operations I did here? Just two operations now. This is one operation changing this 0 to 1, and this is second operation changing this 0 to 1. Okay, so see, we have flipped nums 0, and then we flip nums 2. Okay, this is what we did, right? So total two operations. Okay, so we have to just return the minimum number of k bit flips. Okay, k bit flips, okay, required so that there is no 0 in the array. Okay, see in this example 2. Okay, so here k value is equal to 2. Okay, so this is my nums array na. Okay, so here I am returning -1. Okay, so I want to make all the values as 1 na. I want to make all the values as 1 in my nums array. So let's say if I do like this, it is like this na. Okay, 1 1 0, it was like this. Okay, and k is equal to 2. Okay, so only two bits I can flip at a time. Okay, so let's say I choose this 1 and 0 first. Okay, this 1 and 0. Okay, and now I have flipped both of them. So now I have flipped it to 0 and I flipped it to 1. Okay, this is how my array is going to look like. Overall nums is going to look like 1 0 1. Okay, this is how it is going to look like. Now let's say I have changed these two, then it will become 0 1 1. Okay, so now let's say I have changed it to flip these two bits. Now everything will become 0 0 0. Okay, so now let's say I have changed it. Okay, so now it will become 1 1 0. Okay, so we again reach to our starting point. Okay, so it is not possible to make all the bits as 1. Okay, all the bits as 1. Okay, no matter how we flip sub arrays of size 2. Okay, size 2, we are only flipping the sub arrays of size 2 na every time. Okay, first I flip these two bits. Okay, 1 0 to 0 1, then let's choose any other two. Okay, so it is not possible to make our array equal to 1 1 1 in any case. Okay, that is why my output is -1 here. Okay, so I hope that this example 2 and example 1 is clear. Right, now let's move to the example 3. Okay, so this is my nums array. Okay, so first k is 3 now, so I can flip 3 bits, consecutive bits. Okay, so first let's say I have flipped these 3 bits. Okay, so now my new nums will become like this, 1 1 1, and everything else is same. Okay, then after that I have flipped these 3 bits. Okay, flips num 4, num 5 and num 6. Okay, then after flipping them, it is going to look like this. Okay, so every time whenever I am flipping my sub array of k size, okay, so 1 is changing to 0 and 0 is changing to 1. Okay, this is what happens. So see here, this is changed to 1 here, and these two changes to 0 0 here, right? Okay, and in the end I have flipped these 3. Okay, the remaining 3. Okay, flips nums 5, num 6 and num 7, and then my nums will become like this. Okay, so this is what's happening here, right? So in total how many operations I did? total 3 operations, right? So my output is 3. Okay, so I hope that you guys are clear with the example number 3 as well. Okay, so now let's say how we are going to solve this problem. Okay, so initially this is my nums array, right? So here I have written all the indexes, and here I have created one boolean array, and here I haven't flipped any bit yet. So all the values I have set to false, okay, initially. So let's write the code side by side, okay, whatever we did till now. So first let's calculate the length of my nums array. Int n is equal to nums dot length. Okay, this is done. Then after that we have to create one boolean array as well, right? So let's create that. So boolean is flipped new boolean of size n, okay, same size, and initially flip count value is 0 now. Okay, so here I have to store how many flip counts I did, right? So let me write here flip count initially value is 0. Okay, flip count is equal to 0. Okay, and here let's create one more variable, int current flip count. Okay, current. Okay, if I flip the current value, okay, current flip count. So let's initialize it to 0 as well. Okay, and now after that I have to iterate over all these values one by one now. So I am going to write one for loop for int I is equal to 0, I is less than n, and I plus plus. Okay, this is what I need to do here. Now inside that I have to do something, okay, and in the end I have to just return the total number of flip counts that I did. Okay, so this is a basic things that we need to write. Okay, so now let's see what we are going to write inside this for loop. Okay, so initially, okay, initially this value is 0, right? Initially this value is 0. Okay, and I want to make all the values in my nums array as 1 1 1 1, right? This is how I want to become make my nums array, right? So initially this value is 0. Okay, so let's do one thing now. Let's flip it. Okay, let's flip this bit, okay, from 0 to 1, and we have to flip the bits in the subarray of this size na, k is equal to 3. Okay, so if I am flipping this, that simply means that I am flipping all these bits from 0 to k. Okay, size is 3 na, size is 3, right? So how many bits I need to flip here? So 0 plus k is equal to 3 bits, right? So these 3 bits, okay, 0 1 and 2. Okay, this I have to I have to flip the bits in this subarray. Okay, so here inside this I am going to write first thing. Okay, so let's say I have flipped this. Okay, I have flipped this. So here after flipping this I have to make this value as true. Okay, after flipping this bit, so I am making it as true. Okay, and I have to update my current flip count to 1. Okay, current flip count. Okay, I have to update this now. So current flip count plus plus, so this is going to become 1. Okay, and I need to perform all these operations only when the value of my I is 0. Okay, I plus k, it should be uh, less than equal to n. Okay, only in that case I can make subarray na. If the value of my I plus k is greater than n, then I have to just simply return minus 1 na, because let's say my I is 6. Let's say my I is 6. So 6 plus 3 is equal to 9. Okay, and what is the value of n? N value is 8 na here. So 9 is greater than 8. So I can't form any subarray na. I can't form any subarray of size k. Okay, I can't form any subarray of size k from starting from this position, right? So that is why I need to perform all these operations only in case if my I plus k value is less than equal to n. Okay, this is what I need to do, right? So I hope that this statement is clear. Okay, when we need to perform these operations, so we need to perform only these operations when my subarray size is equal to k. Okay, so this is one thing, right? Okay, so this is done. and we have to set this to true. Okay, so let's write few lines here in my for loop. Okay, so here if okay, so initially my current flip count is equal to 0. Okay, initially my current okay, so let me write it like this. So if the current bit, okay, if the current bit is 0, okay, if the current bit is 0, if the current bit value is 0 and current flip count, okay, current flip count is even, okay, if this is the case, or if the current bit value is 1 and current flip count is odd, current flip count is odd, we need to flip, we need to flip, okay, flip the bits. Okay, this is what we need to do. Okay, so initially initially see here, my current flip count initially is 0 na, right? And if I modulus take modulus of this 0 with the 2, I am getting my output equals to my this value. Okay, this is nothing but nums of I. Okay, so that simply means that I can flip this bit. Okay, I can flip this bit. Okay, so let me write some code here, okay, for clear understanding what is happening here. So first thing that we need to check here, we have to check if the flip operation k steps back affects the current element. Okay, so if my I is greater than equal to k and is flipped I minus k, okay, then we have to just decrement this value current flip count. Okay, I will explain it later why I am writing this. Okay, this is done. Okay, and here I have to write if current flip count modulus with 2 is equal to my nums of I. Okay, and inside that I have to check if I can form the subarray if I plus k is greater than n. Okay, then in that case I have to simply turn -1 na, because I can't form subarray. But if I can form my subarray, then I have to just increment my current flip count, and I have to just update this value is flipped of I set to true. Okay, I have flipped the bit and I have to increment my flip count. Okay, this is all that I need to do here. Okay, so initially this current flip count value initially is 0. Okay, so I have checked this condition first. Okay, I is 0 and 0 is greater than equal to k value is 3. Okay, in this example k is equal to 3. Okay, so I don't need to perform any of this operation. Okay, I don't need to perform. Then after that, here current flip count value initially is 0, right? It is 0. So 0 modulus with 2 is 0 and 0 is equal to my nums of I. Okay, yes, it is equal to my nums of I, right? This value is equal to my nums of I. Okay, so here inside this I have checked can I form subarray. So 0 plus 3 is greater than this 8. 8 is length, na? 8 is the length. Okay, so it is false, so I don't need to execute this thing. Okay, so now my current flip count is incremented to 1. Okay, current flip count is incremented to 1 here, and I have set this bit to true. Okay, I have set this bit to true, and I have incremented my flip count. Okay, so my flip count is now flip count, overall flip count is 1. Okay, then after that I reach here. Okay, when I reach here, so again this step will not execute because my I is not greater than equal to k. Okay, and here I have checked if current flip count is 1. Okay, from last time it is 1. 1 modulus with 2 is 1. Okay, and it is 0 here, so I don't need to execute this thing, right? Because this if statement is not satisfied, right? So I need to move forward. Okay, so now I move to this position, and again here my I value is not greater than equal to k, right? I value is 2 and k is 3, right? 2 is not greater than equal to 3, so I don't need to execute this. Again, I don't need to execute all these operations because my current flip count is 1. 1 modulus with 2 is equal to 1, but my num size is 0. Okay, so this condition is not satisfied, so I don't have to do anything here. Then after that I move to this position. Okay, so see here, until here we have flipped all the bits, right? So my flip count is still 1 here, and my current flip count is still 1. Okay, so now when I reach at this position, then this condition will work. If my I is greater than equal to k, yes, 3 is equal to 3, and is flipped I minus k is true. 3, I is 3, k is 3, so is flipped of 0 is true. Yes, is flipped of 3 0 is true. Now I have changed this bit. Okay, so now my current flip count will be decremented. Okay, so now my current flip count will be decremented, so my current flip count will become 0. Okay, then current flip count is 0 modulus with 2 is equal to 0, but is value of my nums of I at this index, it is 1. So this condition is not satisfied again, so I move forward. Okay, so this will not work. Okay, so now I move to this position. Okay, I move to this position, and here I check this condition. I is 4, 4 is greater than k, but is flipped 4 minus k is 4 minus 3 is 1. Okay, this is not true. Okay, this is not true, this is false. Okay, so I don't need to do anything here. Okay, now here current flip count is 0 from last time. 0 modulus with 2 is 0. Okay, nums I value is 0 in this case. Okay, so now again what will happen? Again I have to check if I can form the sub array. Okay, so if 4 plus 3 is 7. Okay, so I can form the sub array. Okay, so 4 plus 3 is 7, and 7 is less than equal to the value of my 8. Okay, so I don't have to execute this, and now my current flip count will be incremented to 1. Okay, so I have changed here, current flip count will become 1, and my flip count is going to operate to 2. Okay, and I have to set this bit to true. Okay, so I have set this to true. Okay, this I have set this to true. Then after that again I move forward. So here 5 is greater than equal to k. Yes, true, but is flipped 5 minus 3 is 2, so it is not true, so I don't need to execute this. So now see here, current flip count is 1 from last case. 1 modulus with 2 is 1, and my nums of I is also 1 here. Okay, so now this condition is satisfied. This condition is satisfied. Okay, so now here I have to check if I can form this condition is true or false. So 5 plus 3 is 8. 8 is greater than 8. No, this condition not satisfied. Okay, so I don't need to execute. So now my current flip count will be incremented. Okay, so now my current flip count will be 2. Okay, and my flip count is changed to 3, right? And I have to set this bit to be true. Okay, so this is also changed to true. Okay, this is done. Okay, then after that again now my I moves to this position. Okay, now my I moves to this position. 6 is greater than equal to k, true, and is flipped 6 minus 3 is 6 minus 3 is 3, and 3 which is false na, so I don't need to execute this part. Now current flip count 2 modulus with 2 is 0, but value of my num size is 1. Okay, so this condition is false, so I don't need to execute everything inside this if. Then my I reaches at this position. Okay, 7. So now 7 minus 7 is greater than equal to k, true, and 7 minus 3 is 4. 7 minus 3 is equal to 4, and 4 bit is true. Okay, so this condition is satisfied. So now my current flip count is decremented to 1. So now my current flip count will become 1 here. Okay, it will become 1 here, and here I have divided 1 modulus with 2 is 1, but here value is 0. Okay, so I don't need to execute anything here. Okay, so now again now my I moves to this position and is going to out of reach, out of bound, right? So now what was the last value of my flip count? It is 3 now, so here I am returning my flip count as 3. Okay, So see, what is happening actually here? So 0, so here this is my array na, 0 0 0, 0 0 0, then there is 1 0 1 1 0. Okay, so see, every time whenever I am changing my this bit na, so I am changing the bits inside this whole sub array na, so all this become 1 1 1, then this is 1 already, 0 1 1 0. Okay, this is what's happening. Okay, then I don't have to flip this bit, I don't have to flip this bit. Okay, then when I reach here I see that this one order is completed. Okay, this one sub array is completed. Now a new sub array is going to start from here. Okay, so this bit is already one, so I don't need to do anything. So from here next on time onwards it is going to start. So here I flip the bit, so it is going to become 1 0, and this will become 0, and this will become 0. Okay, then I reach here, then I reach here at this position, then from here I can start, right? 1 1 1. Okay, so this is what's happening. Okay, so now let me run the code. So all the test cases has been accepted. Since we are running over all the values one by one, iterating over all the values one by one, so my time complexity is going to be O of n. Okay, now let's submit it. So see, our solution is accepted, right? And it beats 100% of users with Java. Okay, so now let's analyze the time complexity. So see, this time complexity is O of n. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.